Okay, so on this first slide, we're just going to make sure to make a note that for side, angle, side, the angle must be between the two sides. So it has to go in order. It has to go side, angle, side. Okay, so as we get going, it's going to say, hey, identify what you have. So sometimes, okay, so I'm going to give you an example. The example is right here. Okay, that's an example of your side, angle, side. Let me give you a non-example of side, angle, side. So let's say you had two triangles. And it was marked side, angle, mark that. Let's say it was marked side, angle, and then another side. Okay? And when we get starting to identify, okay, we're going to say, okay, I'm going to start here, and I'm going to go side, angle, side. Isn't that side, angle, side? Doesn't that work? And the answer is no, because when, again, right here, the angle must be in between the two sides. That means the two sides have to come together and meet at that angle. So because it is not side, angle, and then this side right here, this doesn't count as side, angle, side. Okay? It actually counts as, so you can catch this, this is actually angle, side, side. What would that be as a shortcut? It wouldn't be SAS. That caught it. That's not a thing. Do not ever write that down on your paper. Okay? It's not a thing. It's never a thing. It doesn't work. And I'm going to show you why in just a little minute. So if you didn't catch that, ASS is not something you ever write down on your paper. Please and thank you. Okay? That's not a thing. It's not a thing. Don't put that down, okay? And believe me, somebody will put it down, and on your paper, I'm going to write, haha, really? Question mark. So don't ever write that down. Somebody will accidentally write it down. Please don't write it down. Okay. Let's go over to this side. Let's go down to this one here. We're going to actually do a proof here. So let's write our two columns. And tomorrow we're going to specifically write out, like every single time, we're going to write out every single situation. We're going to say, when you have a midpoint, what do you use? When you have a bisector, what do you use? When you have parallel, what do you use? When you have perpendicular, we're going to write those all out tomorrow. We just don't have time today because of the shortened class period. Okay, so the given statement first is that WX is congruent to YZ. Okay, that's given. Now, because I wrote that down, I'm going to go ahead and mark that on the picture. So WX and YZ. So over here, I'm also going to tell myself, hey, I have a pair of sides. On the side there, I'm going to say, hey, that's a pair of sides. Okay, then the next given statement is that I have parallel lines. Okay, so WX is parallel to ZY. That is also given. Okay, so we're working on our logic and reasoning skills. Logically, what does that tell you to do next? Okay, and that's what we're learning. So logically parallel opens the door for things like corresponding, alternate interior, consecutive interior, and alternate exterior. I'm going to tell you, especially as we move forward, check alternate interior first. If you don't have alternate interior, check corresponding. Those are the two most likely options. Okay, so I'm going to go ahead and just highlight these lines for us. Okay, so here, this line is parallel to this line, and this is your transversal. Okay, so with those highlighted, it helps us just a little bit to see. So I kind of made like a Z here. And so I made a backward Z, but you see that here? Like that? So we go down, and over. And inside of the nooks of that Z are where your congruent angles are. Okay? So right in here, so I have to go from the parallel line to the transversal, that's one of your congruent angles. And from the parallel line to the transversal, that's your other one. What's going to be common is you're going to want to say maybe that this angle down here is congruent to this angle up here. Those are not congruent because they don't have anything to do with the parallel lines that you were given. Okay? So that's the other part that's kind of tricky is because it's parallel, you want to look for alternate interior, which is what these are, but which angles by alternate interior. And it is a very specific pair. So it's those two angles right there. Okay? So this doesn't give us anything, but I can right here say angle. I'm going to go X, W, Y. Congruent to angle ZYW. Those are alternate interior angles. Okay, that is a pair of angles. So off to the side, I'm kind of just setting myself up with what letters. Is this going to be side, side, side? No, because I'm introducing an angle into the proof. Okay? Okay, so process. Step 1, you write the given. Okay, I did that. Step 2, you use the given, looking for a definition of or an alternate interior or something like that. Check. Got it. Alternate interior. Third thing, do I need something else? Yes. You need 3 letters to be able to say that the triangles are congruent. So far we know side, 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 and then side, angle, side. That's our new one. I don't have that. It just has a side and an angle, so I need something else. If you need something else, get it from the picture. Anybody, because of what we did yesterday? What are we going to use? X, Y. I would love it if we could get that, but do you know why? Okay, so that's a great thing. So we want that. That would be great if we had that, but I have no reason for it. Okay, so let's take that out as an option. What's the other side length that I don't have marked? Okay, and WY for the first triangle would be congruent to WY for the second triangle. Do you know why can you say that WY is congruent to WY? Do we have a reason for that? Because they're the same thing. Okay, so I do have a reason for that one. So let's go with that. Good. So sometimes you're going to want something, but if you ask yourself, why can I say that, and you don't have a reason, pivot and try something else. Okay, that's a good process for us to go through. Thank you. So WY is congruent to WY because they're the same thing. This is the great part. If you were writing paragraph proofs, which is what we do in college, you could just write because they're the same thing. But because in a C-chart proof, you have to use an actual property. You got to use reflexive property. I'm looking at myself in the mirror. So the reflexive property of congruence. That's the property there. That is another set of signs. Once you have 3 letters, okay, so I've got my side, my angle, my side, I've got my 3 letters, I'm ready to say that the triangles are congruent. I'm going to take just a minute to go ahead and mark that reflexive. And look to see, is the angle that I got actually in between my 2 sides? Here's my 2 sides. Do those 2 sides come together where the angle is? Yes. So I got side, angle, side. Side, angle, side. And that's when I'm going to say my 2 triangles congruent, which is right here in that proof statement. The triangle WXY is congruent to triangle YZW. Okay, so we saw parallel. Yesterday we saw bisector, I think. And then today we saw parallel. We're going to see bisector again. So I'm going to slide this over here. We're going to do another proof. And the only thing that's different for this one is that the given is different. Okay, so let's go ahead and get our chart set up here. Statements on the left, reasons on the right. So MP is congruent to NP that is given. If that's not marked on the picture, you want to actually go ahead and mark it. But this time it's marked, so I don't have to do that. Okay? That is a pair of sides congruent. Okay? Yay, check that one off. All right. Don't have anything to do with that. Nothing I can do. Okay. Side angle side. I'm just going to slide that back over there for you just a second there. Because you're asking for this guy right at the bottom, right? Yeah, side angle side. I'll put it that way. Thank you for asking for that. Somebody else can do that. Okay, so I've got that. There's nothing I can do with that, so I have to move on. There is another given. If there wasn't another given, this is where I would look for something from the picture. But there is another given, so I'm going to go ahead and use that other given. It's that OP, the segment bisects, that's a vocabulary, angle MPN. Okay, so because it says bisects right there, it should be a red flag. If it says bisects, yes, definition of. But that's only half the battle. Like, I know it's supposed to be definition of, but what do I say by definition of? So now you actually have to use your logic skills and your reasoning skills and figure out what am I actually going to say by definition of. Okay, this is what it's saying. OP is cutting this angle into two equal parts. So we need to go to this angle, MPN. Grab my highlighter out again. MPN. And you need to cut that angle into two equal parts. So I'm going to use my arc mark to show that it's being cut into two equal parts. That's going to be this one and this one. Those are my two equal parts. Those two parts right there are what's going to go on the left side. So when I write the angle measures, I'm going to start at M. You can start at O if you want it. It doesn't matter, but P has to be your middle letter. That's the part that matters. So I'm going to go MPO is congruent. Now come over here, NPO. So we're going to go angle MPO, NPO. Now that's a pair of angles. So I know that my side congruency is out. Okay, that's not what I'm using here because now I'm introducing an angle. Okay, I wrote my given, check. I used my given to get my definition of bisect statement. Okay, now I need my obvious from the picture. And I say obvious because isn't it obvious that OP would be equal to itself? Yeah, it's the same thing. So there's always going to be something from the picture, and it might be something that seems obvious, but we still have to write it down. So OP has to be congruent to itself, OP, and it's going to be that side where they come together. Where the two triangles come together, that's going to be this one here, OP. And it might seem obvious that OP would be congruent to itself, but we still have to write it down because I need three things. Before I can make my triangle congruency statement. So 2 days ago, we needed 6 things. So that's why these are called triangle shortcuts, because there is 5 different combinations that you can use that will still show the triangles congruent. So one of them being side, that's not this one. Another one being our side angle side. So that's what's going to go here. One of our shortcuts. And what I can say by side angle side is that my triangles are congruent to each other, which comes right from this proof statement. So MOP, triangle MOP, is congruent to NOP, and I got that right from that proof statement above. Okay, those are our two practice proofs for side, angle, side. Okay, so now we're going to talk right here. This is the picture, okay, as to why SSA doesn't work. So this is the way of making this conversation school appropriate, is that we say the letters backwards instead of forwards, right? So there's a chance that when you write, so I said somebody's going to write it on their paper, right? When you write it on your paper, you're probably going to write it this way. You're not going to realize that you're writing backwards. Okay? So this is how we make it school appropriate. SSA is not a thing. Okay? It's not a thing because, so here's an example. I have two sides that are congruent to each other. I have this pair of sides, this pair of sides. So those two sides are the same length. Then you have this side here that's the same length as this side here. But the angle in between them is not the same. That's why it's not a side angle side. This angle here is an acute angle. This one, maybe right, maybe obtuse. It's right on that border there. But these are definitely not the same angle. So this is not a side angle side situation. So if I preserve the angle at the end of one of those sides, those two angles are the same angle, what happens is this side here can pivot to this location or this location. So just having this side and the angle at the tail end of those two sides being congruent does not ensure that these two triangles will be the same. Okay, so not every combination of the letters S and A are going to give us congruent triangles. So SFS works, SAS works, but is everything going to work? No. So this one does not work. Okay? And you can remember that it doesn't work because it's not true. So this is not something we should ever write on our test. Okay? Because it's not a thing. Unless. Right? There's always that catch, right? Unless that angle measure right there happens to be 90 degrees. If that angle measure is 90 degrees, it actually does work. Why? Do you have a question? Well, see, like I said, math people are smart. Math people are smart because we have to make this school appropriate, right? So we just give it a different name. So there's a different name for when the angle is 90 degrees. Now let me just explain why it works when it's 90 degrees. If it's 90 degrees, it's a right triangle. If it's a right triangle, you can use Pythagorean theorem. Okay? So if you can use Pythagorean theorem, and this side was like 5, right? And this side was 4, and by the Pythagorean theorem, this would have to be 3. If this side were 5 and this side were 4, by the Pythagorean theorem, this side would have to be 3. So because it's a right triangle, and things like the Pythagorean theorem, it's actually a side-side-side situation. Because you can prove that the other sides are congruent, but it just takes too long. Okay? So, that is a great question. Should we call it SSA if it's a right angle? No. There's a different word. So the different word is right here. It's hypotenuse leg. It's HL. So HL is the other one that we're adding today. HL is a special case of SSA. And it's when you have a right triangle. So what's hypotenuse again? Remember that hypotenuse is the long side of a right triangle. So over to the side here, if we want to just label a right triangle, if you don't remember those things, this is the hypotenuse. And these two other sides are the legs. So you just have to have the hypotenuse and one other side. So it doesn't have to be a particular side. It's just one of the other two sides. Hypotenuse has to be there, the 90 degree has to be there, and then you also need another leg. So this is one of the 5. So we now have 3, and we'll learn the other 2 next week. Okay. So here's what we've got. We've got on the back side, we just got some examples of identifying hypotenuse legs, and also a proof for hypotenuse leg. Okay. All right. We are running a little bit short on time, so perpendicular does not show up a whole lot in proofs. So in order to do this in a little bit more of a timely manner, can we just put a 1 right here and a 2 right there? Just so that when I write angle, I don't have to write the 3 letters, and I can just do it a little bit faster. Okay? All right, so here's our proof. Okay, so YW is perpendicular to XZ. That's given. Okay. If you have perpendicular lines, do you have 90 degrees? Yes. And that's all you need for HL. For HL, all you need is 90 degree angles. Okay? So I'm going to say right here is I'm going to say angle 1 and angle 2 are right angles. Okay. Why? Why can I say that? Well, there's a vocabulary word. So what comes after a vocabulary word in a given? Definition of. Okay, so the definition of perpendicular is that 2 lines come together to form right angles. That's what I said. I said I have right angles. Okay, so I have right angles. I can mark those as right angles on the picture here. And there's something else in the given. It's XY is congruent to ZY. That's in the given. I'm going to go ahead and mark that on my picture, XY and ZY for the given. So I write the given, I use the given, and then I get something from the picture. Okay, my something from the picture is either vertical or it's reflexive. Linear pair would work as well, but we're not going to use that as much. So the reflexive side in the middle, that WY, congruent to WY. I can mark that in the middle there. And so when you're looking at a problem and you're kind of trying to figure out what you have and you're pointing them around to yourself and you're like, okay, so I have an angle, so that's A, and then I have an S, and then I have an S. Don't write that. So if that happens and you find yourself writing that, you're like, whoa, wait a minute. Is it HL? Because if it's not HL, then we did something wrong, okay? But if it is HL, that's because you have a right angle. So that's a special case of a right angle, but we just pivot a little bit and we give it a different name so that we don't have to use that word. Okay, so triangle XYW is congruent to triangle ZYW. Okay, so there's 3 of our 5 congruency statements. Okay, so this is what you might see on your homework tonight. You might see a couple of questions where it says, if I have this and this, what else would I need to have side, side, side? Okay, I would need another side, right? To use the picture to make those markings, we will kind of have a separate day, if you will, tomorrow to kind of make sure that you feel comfortable with all of this stuff. We're going to give you this. So I know I didn't get any questions on last night's homework, but we will definitely do that in class tomorrow. It is a short day tomorrow as well, but not as short as today was. So there is study table tomorrow. It is a geometry study table day. So make sure you check your email to see where you're supposed to go for study table. Also, if you don't know what lunch you sure you're asking is your lunch with your 7th-hour class. So whatever your 7th-hour class is,